Well, we got a list of directions over right on the board. What should we do first? Yep. Let's create an array. And what should be specific about that array? Okay. But what specific feature do we need this array to have?
Range.
It's going to have a range. But there's something about using arrays in Objective-C that we're not used to from Swift. With Swift, we could just create any array. We could append anything to it of that type. But we actually can't here.
You have to set the type.
We don't have to set the type. Nima, do you want to give it a try? Yep. And why does it have to be mutable? Okay. What are we going to use it for? What are we going to do in our for loop? Okay. And how do we get things into arrays? What's the word? Awesome. So this needs to be a mutable array so we can keep appending to it. That means that by default an NS array doesn't let us append things. It's a static type. Whereas something like an NS mutable array is what we call a dynamic type. And let's just be super careful with this word here, static, because it means something specific in Swift that it does not mean here. Static means that it can't be changed. Static does not mean something like static var or static func. Static means that it's stuck how it is once we create it. All right. So, Albert, can you help me with the syntax for creating an NS mutable array?
NS mutable array.
I love it. Okay.
You gotta take that type.
That's the type.
I can't search it. Oh, that's the side for each variable.
Sorry.
Was it equal something? Try to get it out. Give it a name.
Give it a name. Okay. What do you want to call it?
Mutable array.
Mutable array. Amazing.
You gotta put that little star.
We got to put the star. Do you remember what that star is indicating?
It is as a pointer.
Yeah.
Right.
So we have a pointer to an object because everything in this NS library, this foundation library, is a pointer to an object. Keep going. You're doing great.
Now you put a bracket then.
Cool.
Then what are we gonna have inside of it?
What am I going to have inside of it?
What are we gonna have inside of it?
Well, what's the question?
Create an array containing alphabet numbers between 1 and R. So I'm just saying 1 dot R C. That's what.
I'm going to pass this to Rod. Rod, I want to just start out by putting into memory and initializing an NS mutable array.
I believe NS mutable array.
Awesome.
And then the specific thing you want to do with that array.
Okay. Let's say I want to make an empty array. In Swift, we would do something like this. First, var array is declared as an array of ints. But what does that not have, Rod? If I tried to access any index, could I do that?
No.
Okay.
It's
Isn't-
not additional.
not initialized. That's great. Array is equal to maybe an array of 1, 2, and 3, and also 4. Amazing. So here, what we tend to see is when we're creating objects in, what is this language called? Objective-C. Thank you, sorry. We actually need to say we're going to start out by declaring some space. So allocation is what that alloc thing is short for. And then we initialize it with an empty value. This is just like, this init right here is just like having something like, let's say this, in Swift. So now we've got an empty array. And Aaron, I've got a red error. What do you think that red error is?
Error.
Right here.
It's an error.
I know. Why do you think I'm receiving it?
Syntax.
Cool. What about the syntax?
It's not right.
We're narrowing in. Do you want to read the error?
I'd rather just guess at it. I bet you it has to do with maybe an Objective-C symbol that you're missing, or asterisk, or semicolon.
Cool.
Semicolon.
Tell me something about Objective-C. What must every expression end with?
Semicolon.
Awesome. Thank you. All right, now we're going to get a warning because by default, all of our things that we declare are variables. So this is a variable. It's saying unused mutable array. Well, let's go to step 2. Then we're going to loop through. And what are the conditions of that, Alex? What are the conditions of that loop? How long do we keep looping?
Until arc finishes.
Yep. Loop through until we've reached arc C. Where do we start?
1.
Starting at 1 until we've reached the int value of arc C. Yeah. And with each iteration of the loop, what do we do to our iterator, that letter I?
Running it to the array.
Yep. Thank you. That's great. Each iteration of the loop, append I to the mutable array. Awesome. Can I get a volunteer to make our for loop? Can I tag a volunteer to make our for loop? Liana, can you create our for loop? Thank you. That's a great word to start for loop with. Now we got 3 things. Int. Int I. Cool. Do you want to give it an initial value? Cool. So this is the thing we're going to be evaluating in some way in this condition. What's the condition going to be? Awesome. And then with each loop, how do we want I to change? Cool. So I plus plus increases the value of I with each loop. This is the format you will see almost all the time. It doesn't mean it's the only way that you can use a for loop. We could be decrementing, which would actually create an infinite loop because we would never have a false condition. We could just say I minus 2. So remember this format of this for loop because it's not always just counting from low going up to high. It could be something else. All right. Inside this loop, what do we want to do? How do I do that? All right. So a mutable array, probably just like a Swift array, probably has an append function. When we talk about objects, How do we call a method? Or there's probably a better name. Jason, I'm going to ask you, what's like the better name in Objective-C for calling a method on an object? It's like, it doesn't change anyone's world, but it's kind of like a vocabulary term that we went over last time. Okay. Sunny, what do we call it?
Sending a message?
Yep. I'm sorry? That's what the mafia does. When we append to our array, we send a message. And then, what's a good emoji for sending a message? Knife. All right. So when we append to our array, we send a message. What's the syntax for that? Anthony? Yes. Sorry, say that again. Add. Okay. So can you talk me through how to type it out? Awesome. Add object. Cool. Now what am I going to add? Parentheses and the at symbol. Like this? Interesting. Cool. So what are you doing here? Can you tell me? What's that type of that string? So it's actually, add object is referring to something in the foundation library. There's a specific type that this at quote quote I gives us. I'm going to tell you, it starts with this. So this at notation is called literal notation. It's a shorthand. It's one of the few shorthands we have for creating objects in line like this. Otherwise, we'd have to create a string variable name is equal to this thing. This is one of the few shorthands we have, the literal notation. Cool. All right. Is that all we need to do in there? Sounds good to me. Great. Now, how do I do this last part? Print the count of the number of elements in that array. All right, I'm going to start. Print mutable array dot count. That should work, right? Tell me that again.
It does seem to recognize print as a method.
It does seem to recognize print as a method. I agree. Not in the way we want it to. Implicit declaration of function print is invalid in C99. This function declaration is not a prototype. We're going to talk about this whole concept of prototype more next time when we get into inheritance and how it works and how it doesn't work in the way we're used to. But print is something available to us in what we call the global scope. And it's not quite one we want to use here. What is something that's also 2 lines down from where the cursor is that we can use to print something out? Yes, thank you, Kibble. So let's use an NSLog. And Eric W., how does this NSLog thing work? It's kind of like a print, but there are some differences. Can you tell me? Okay. So that at is the literal notation. Cool. Let's say I want to say, when I print out the count, that the message here is there are some blank number of objects. How can I get that in there? Cool. Cool. So we use this flag or this token. And why do we use that? What can't we use in an Objective-C string that we're familiar with from Swift, that we miss, that we love? What does it not have for strings? I bet you do know. How are you used to adding information to strings that aren't necessarily strings? Yep. So we can't do that anymore. Instead, we use these flags or tokens. Cool. So I'll type out the rest of the phrase. There are blank items in this array. And then how do I actually get the value of that blank in there? Sorry? Comma I. So we're actually no longer in this loop here. We're outside of it, so we don't have I anymore. What value do we want there? Looking at an array, we want to know something about it. How would we get this in Swift? Swift, we could get the number of items using, how would we do that? And if you remember, with all objects, calling an instance method is just the same as what we call sending a message. What's the notation for sending a message? On line 26, we're also sending a message. Cool. So we start with an open square bracket, and then we reference the object that we want to send a message to, which is what object? What's the variable name? Yep, mutable array. And now, after the space, that's where we'll actually call that function or access that property just like we would .count. So what do you think we can look for in this array? So count number of objects in the array. You want to run it? Looks great to me. Let's see what they say. Values of type NSU integer should not be used as format arguments. Instead, add an explicit cast to unsigned long instead. Replace %d in this array with %lu. All right. So like we talked about last time, there are some pretty simple formatter tokens, but there are also some specific ones. This NSU integer is not like most of the foundation set, an object that has all these operations on it, but instead it's usually just a representation of something like a long int or a float or a double. It doesn't have as much functionality. Just be aware when you see NS integers or NSU integers that you don't have the full NS number library behind it. It's different than that. So we used a different formatter flag Thank you, Xcode. You're just as smart as when we use Swift. Super helpful. All right, so we've got our array. We allocated some space to it, and then we initialized an empty one. Then we added the letter I, which, for this problem is definitely going to work. And then we printed out there are some number of items in this array. Should we run it? All right. Well, I hope it works. There are 1 items in this array. Perfect. So, if there are 1 items in this array, this is the logic problem to end this warm-up. If there is 1 item in the array, how many arguments are there in main, the main function here? Two? Well, think about how many times this loop gets executed.
Is your question how many arguments there are in the main function?
So argc is just the number of arguments coming into this main function. We can actually add arguments when we hit that run thing. If we did it from the command line, we could say, let's execute this file. And we'll do that in just a sec. But if this loop starts at 1, then it says 1 has to be less than or equal to argc, and then 1 gets bigger. And then it adds an object. How many items are in argc? Let's see. How could we do that really quickly? Yeah, let's just print it out. argc has, I don't know, what's the flag for an int? %d has %d arguments, and then we'll just put in argc there. Interesting. argc has 1 argument. Amazing. Amazing. So, the unfortunate part here is for a range, we have to use a for loop. For a for loop, we have to make sure that we are thinking about how that range actually works. And then, on the other side, we're using this foundation library to add stuff to a mutable array, count the number of things in that array. Would you all like to see how we add arguments before we take a break, because it's really warm in here? All right, let's do it. I'm gonna break out my command line, I'm gonna clear it out. I'm gonna remove this old thing I had there. How do we run this in the command line, if you remember? What did we do? Like, high level. I used this thing called clang. Does anyone remember what clang is? It will, so it's not going to run our program, which is actually a little different, but it's the step before running it. What's that step called? Yep. So clang is the compiler for, in our case, Objective-C. Let's just add a note. We can add command line arguments by using the clang compiler. All right, so clang, and then I'm just gonna press the up arrow because the rest of this is just a syntax that you can copy from here whenever you want it. But we're saying clang, compile an Objective-C program from the main.m file, and then call it exec1. Cool? Now, if I look at what I have in this directory, I have my main.m, and I have this red scary thing called exec1. And to call this, I can just call exec1. But what specific thing do I need to tell my terminal to make sure it's looking in the right place? It's weird. Dot, yeah. Think about git. When I say git add dot, it says add everything in the current directory. Dot is a set of functionality referring to the current directory. It's not just a git thing. So I could say dot, meaning look here, and then in the current directory, run exec1. Great. So we ran it there, but now I can say, I can literally just enter arguments. So I could say, let's use this flag t. What does this flag t do? No idea. But I could just keep adding arguments as if they are, these are arguments to our non-coder friends. To add an argument, you either use a word or put a series of characters in quotes. Cool. All right. Question for you all. How many arguments are there here? I heard 4. I heard 4. I've also heard 4. Okay. Let's see. There are 6. Why are there 6?
Well, there was already one that we started off with.
What was that one?
The one, the for loop.
So by default, our Objective-C, what is this called? Program. Our Objective-C program is going to give itself the name of that program as an argument. And then from there, remember, this is an Objective-C program, just like a Swift program. We would have to interpret what this -t, what this something, something, and these sentences and quotes mean. Argc is just counting the number of times it sees things separated by spaces. That's what an argument in a command line is. It's just a thing separated by some spaces. This -t, like when we see a -a or a -m, we're used to it being some kind of option for like Git or for creating new repositories and stuff like that. But our Objective-C program is the prefix here. We could do git add in the same way when we do exec1. What we're kind of doing is leading with objc, something like that. It's not a real command, but we're saying feed these arguments into our program, which happens to be an Objective-C program. So we could read those arguments in our main function. We could do a whole bunch of stuff with them. That's not really that important. What is important is that we can always be executing this Objective-C code from our command line, and we could be running it. So this is kind of how like scripting with computers works, is you make a program, and then you send it information from a terminal or from a command line. And that's how we can create programs that don't need to be run from Xcode, that we could actually run the simulator from our terminal. We can do all this, what I think is exciting stuff, but applies to pretty much every programming language. Every program has to run in some manner. If you created a web app, you'd have to run it in some way. If you create a Swift app, you have to run it in some way, and so on and so forth. Sunny.
You would add arguments into a project, so you would add code in a string like this?
You could add code in a string as like options. You could say run this program in this way if you see the word something with capital S as opposed to lowercase s. You would parse through the arguments to get more information in your program about how you should run the program. This is another level of abstraction, basically. You could present an entire program to someone, and you could, after presenting that program, tell them, hey, if you want this program to work this way, enter this argument. We don't implement Git. We don't actually like make the code work for it, right? They've abstracted all that behavior out for us into a program that we can run from terminal. And it's pretty cool. Like, that's how software works on the lowest level. And
If you were to do another dash T and then add another argument, would you get 8 or 7?
let's try it out.
I'm missing where it's 6 or 5.
So we've got in quotes how many strings or sentences. Cool. And then we had 1 dash T here. We get 8 here because by default, we don't see it, but by default, when you run an Objective-C program into the main function, its first argument is the name of that program. So where it is on your computer and some other stuff that you can find out about it. And then everything else that we add as an argument in terminal gets added as a new argument.
Right. I guess my question is, you start off with 1 argument initially, right?
Mhm.
Is that 1 initial argument the name of the, what did you say it was?
The program.
Yeah.
Yep.
And then you added 4 quotations.
So it even interprets this dash T. It doesn't even know what to do with that. Yep. Cool. All right. What are some more questions? Sunny?
This is how, can you give an example of a type of software that you would be creating?
Sure. If you worked in another framework called Flutter, you literally run a Flutter command to run a program, just like you would with Git. You could compile in Flutter my program 1 in the same way that we created one with Objective-C. You could then add some options to it. All that's encapsulated by this Flutter package. What we're doing is kind of saying we've got our own program, and I could actually send you this executable 1 file, and you could just run my program. I could just send you this thing, this compiled program, and you could just do ./exec1 without sending a code base, without anything like that.
Program in this case being a Mac OS app.
Being a Mac OS command line app, yep. This is how things get distributed. This is how things get created, compiled, blah, 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 blah. Let's take a 7-minute break. Come back at 11:07.